Hey guys, welcome back to day 11. So in this question we get given an input array that looks like this, and each of these is a stone. We have to blink 25 times in the first part and 75 times in the next part. And what a blink means is that we go through the list of instructions, and then for each number we have to apply these rules. So the first rule is if it's 0, add 1 to it. If the second one, if it's an even number of digits, we split it in half and then add both halves back to the array. And then finally, if none of the other rules apply, we multiply it by 2024. In the question, it says the order is preserved, but actually it doesn't affect the results of how you're supposed to calculate the answer because the results don't care about the order. Yeah, I'll just show you the code for part 2 because, yeah, part 1 I did a brute force, but then it timed out. So for part 2, I just optimized it. So what I have here is I have a DP because you can imagine with the question when you're simulating it, there's a lot of repeated calculations. So this DP fixes that by, yeah, storing them so we don't have to repeat them multiple times. And it runs like, millions of times faster. So yeah, what we have is this DP. It's initially set to repetitions plus 1. That's because, say for in the part 2 we have to repeat or blink 75 times. So here I've just declared a dictionary, I guess 75 or I guess 76 different dictionaries. And for each dictionary we can say we say access the DP at index 10, we can say when you have 10 blinks left, this is the values that are going to get calculated for each of these numbers. And you can see at the end here, we say in DP position 75, going through the starting array, what are the values that we've calculated for these? And then if we look in the DFS function, you can see, if we've got no blinks left, that means we've already reached the very end and we can return 1. Otherwise, let's check if we've calculated before. Otherwise, let's just reduce the current blinks by 1 because, every time we blink, we want to reduce that by 1 so we don't, go forever. And then, yeah, if the current's 0, we just add 1 to the current and we update the DP. Otherwise, we check that even number of digits case, and yeah, we split it into the left and to the right. And then here we add the left value to the DP value and the right value. And then finally, here's the 2024 case. And that's it. Thanks for watching.